Good morning, children. Hope you are doing well at home. So, in our today's topic, we learn about magnification formula. In the previous classes, we have already learned about mirror formula and sign convention rules. So, now we'll see what is magnification and what is its formula. Magnification gives the relation between object size and image size. We already know about object size and image size. Object size is nothing but it is also called as height of the object. Here in this diagram, I have represented it with O dash. At point O, an object is placed whose height of the object is represented with O dash, whose image is formed at the point I dash, that is the height of the image. Okay, size of the object is also called as height of the object. So, it is the ratio of size of the image to size of the object. Okay, magnification tells about the ratio of size of the image to the size of the object. Magnification is also expressed as the relation between object distance and image distance. So from the pole, here object is at certain distance and image is also at certain distance. So in terms of the object distance and image distance also, we can define the magnification. We can also derive the formula for that. As shown in the diagram, a ray started at point O, incidents on the surface of a concave mirror at point P and reflects. At point O, actually, the object is placed. So, O dash is the height of the object, which is placed in front of the concave mirror upon the principal axis. In this diagram, this is the ray diagram representing the object placed beyond the center of the curvature in case of the concave mirror. This is the principal axis of the concave mirror. This is midpoint of the mirror, which is called pole, focal point, center of curvature, and at the point O, an object is placed. This is the height of the object, O dash. And here, two incident rays are coming, and when they incident on the surface of the concave mirror, they will reflect. Here I have represented two incident rays which are coming from the top of the object. One incident ray is going parallel with the principal axis. This is the principal axis. The first incident ray is going parallel with the principal axis. Hence, upon reflection, its reflected ray passes through the focal point of the mirror. Okay, I have represented here upon this reflected ray is passing through the focal point. And second incident ray, which is incidenting on the pole of the mirror, by making the same angle, it reflects. Whatever is the angle of incidence, the same will be the angle of reflection with the principal axis. Okay, so these two reflected rays, upon reflection, we have to represent the two reflected rays like this. And these two reflected rays meet at a point. On this point, we will get the image. So this is that point. Where do we get the image? Okay, this is the image and it is below the principal axis. It is downside to the principal axis and it is inverted. So I dash represents the height of the image. See, O dash is the height of the object and I dash is the height of the image. Now, in this diagram, this triangle PO dash, PO dash. If you join all this, it will look like a triangle PO dash. This is a triangle, and similarly, PI dash is also another triangle PI dash. PI dash. When you join all these three points, you will also get a triangle. So in this diagram, the triangle PO dash and the triangle PI dash are similar triangles. Hence we can write as I dash by O dash is equal to PI by PO. I dash by O dash, that is nothing but height of the image by height of the object, is equal to Pi by PO. Pi by PO. Pi is nothing but the distance from point P to point I indicates the distance of the image. Here I indicates the image. So here the point where the image is formed. So P to I, this distance is the image distance. From P to O, this is the distance of the object distance. Okay, so this is the equation number 1. And according to the sign convention rules, see here, PO is nothing but the distance from point P to point O is the object distance that is represented with the letter U. And as we give the sign convention for this should be written as the minus U, because we have to move in order to measure the distance of the object. We have to move from the pole towards this side. So towards this side, from the pole towards this side, object side, that is in the right side direction, which is the opposite direction to that of the direction of the incident light ray. Hence we have to take object distance as minus U. Pi is equal to minus V. Pi is equal to minus V. From the point P to I, the distance is called image distance, and image distance is represented with the letter V, and it is also measured from the pole towards the image, that is towards the right hand side, which is opposite to the direction of the incident light ray. Hence V is also should be taken in the negative quantity. Pi is equal to minus V. and O dash is the height of the object, I dash is the height of the image. Height of the image should be taken as the negative quantity here. Height of the image, because the height of the image, we have to measure the height of the image by going in the downward direction from the principal axis. The measurement which is taken by going in the downward direction from the principal axis, that will be taken as the negative quantity, and object is from the principal axis in the upward direction, hence it should be taken as the positive quantity. Object height, O dash is the height of the object which is taken as the positive quantity, whereas I dash is the height of the image which should be taken as the negative quantity. Now according to the sign convention, we have written all these things, all these values, and now substitute all these values in the equation 1. This is the equation 1. On substituting all these values here, we get I dash means minus hi. Okay, this one. O dash means ho is equal to pi means minus v. Okay, minus v. Po means minus u. So minus u. After writing all these values here, this minus sign and this minus sign both will be getting cancelled, and we will get that implies hi by ho is equal to minus v by u. Hence, the magnification is equal to m is equal to, see children, magnification is represented with the letter m. It is denoted by the letter m. So m is equal to, what we will get, we can write it as m is equal to hi by ho is equal to minus v by u. This is the magnification formula, and therefore we can write it as m is equal to hi by ho, and this is in terms of the size of the image and size of the object, or in terms of the heights of the image and height of the object, magnification formula. And this magnification can also be expressed in terms of the object distance and the image distance. Already we have seen that point. So according to the object distance and image distance, we will write it as m is equal to, magnification can be expressed as m is equal to minus v by u. Okay children, this is about the magnification formula. Wherever we are using the magnification formula or mirror formula, whatever it may be, we have to use the sign convention in every situation.